Today we're talking about coral, okay? In coral, this marine biologist, I don't know his name, we'll call him Ronnie, okay? Ronnie, he estimates that a structure of coral has a volume of 1,200 cubic centimeters. So that's volume. And that volume doubles each year. You guys know coral is like alive, kind of? Yeah. So it's doubling. You need to write an equation of what's happening with this coral reef. Then you need to try to see what happens with inputs of 5, 1, 0, -1, -2. What could -2 possibly mean? And then, in a certain year, the volume is 37.5. Which year is that? Let's go. With your partner at your table group. The first thing I need is some help writing the function of the situation. So, Sean?
Y equals 1,200 times 2 to the t.
Yeah, now the little pop quiz I've been giving everybody, and I just keep asking this kind of question because I know it's counterintuitive and difficult. What's the percent of growth for this? So it's times 2. What's the percent growth?
Oh, it's
I got a 300. Vinny? What percentage more is it going every year? Lily? It's 100% growth. Because 100% is how much change? No change. So the 2 is 200%. 100% of that's no change. 100% growth would get me to 200% of the original. I just keep throwing that out there because it's like a challenge. I see 2. I think 200%. Anybody else? Yeah. But it's actually 100% growth. So we've got our function. Now we need to test up these different numbers. So instead of writing all this substituted in, just know all those are going to go in there for what letter? T. So these are different times. So for 5 years, I got 1,200 times 2 to the 5th. I got 38,400 cubic centimeters. Okay, for 1 year, I'm going to do that one in my head. 2,400 cubic centimeters. For no years, 1,200 cubic centimeters. For 1 year in the past, 600.
300.
And 2 years in the past would be 300 cubic centimeters. Now, you can just make a pattern. Anybody do a table? A table kind of looks nice on that too, because you can just see the pattern. So what does it mean when t is -2? Who can, in context, what does that mean? I kind of already gave that away. Okay? Yeah. So when t is -2, that means 2 years ago, that would give you the coral reef. And this is like a really applicable, real science thing that happens. I don't know about coral. Probably with coral they can do this. But definitely with carbon dating. And did you guys do any carbon half-lives last year in science? Sometimes 6th grade does it. Essentially, they can find something really old in the ground and say it has this much carbon in it. But we know carbon gets halved every this many years. And they use negative exponents to backwards generate when that carbon had to be a living thing. Because carbon is all kinds of things. If you hear carbon dating, it deals with a carbon half-life, which is an exponential function where they use the negative exponent to backtrack what it would have been. Or on Mars, I don't know. Carbon's like up all over the place. But so next, when was it 37.5? Well, what I did was 2 years ago. Table's great. 2 years ago, I was there. Okay, we had tables. Is there any other ways that people got it, Ivy?
Well, I mean, I just like this might not be like efficient, but like
Yeah.
I already knew -2, so then I started with -3, then -4, then
That's essentially the table. So that's what I did too. I was like, I'm at 300 at -2. I half that, that's 150. I half that, that's 75. I half that, it's around 37.5. So 3 more times after the -2 means 5 years ago. And this is really good too, because if we can establish a relationship and we can measure it like today, we can find out what it was without knowing what it was. It's kind of like being a detective, a math detective. This lady, I'm going to call her Betty, she took some medicine. Probably not, but she took some medicine and she doesn't know how much she took. But here's what we know. She did get her blood tested. And when she got her blood tested, there were 100 milligrams up in there.
Is that a lot?
It depends on the medication. We don't know the medication. We just know 100 milligrams when she got tested. And then she got tested 1 hour after that, 2 hours after that. It's your job to figure out how much was in her blood at different times and solve the mystery of how much medicine this lady took. Closed, please. So I'm looking at -1 hour and -3 hours. What does that mean, negative hours in context?
How many hours before blood?
Hours before blood test, right? So it looks like what's happening to my medicine each hour?
It's getting less and less.
Less and less. So when I make my function, I'm going to say my original value of 100 for when I got tested, or she got tested. It's half as much being metabolized or used each hour to the t number of times. So I like to, we can make a function so easy now that I like to just start function, right? So if I go back 1 hour before the test, how much had to be in her blood? 200. 2 hours ago would have been 400, so 3 hours ago would have been 800. And by the way, you slap a -3 up in there for t, you got 800. Right? Are we all set where we're at so far? So in context, t of 0 means what? When the blood test happened, right? The first one. I'm going to put first blood test. And Meredith kind of helped us out already. -3 means 3 hours before the test. Okay? We don't know how much was there before, but we can take our relationship and backwards generate using time travel.
That's pretty cool.
Yeah, if you want to learn more about time travel, you can watch the documentary Back to the Future. Maybe we'll save her life, okay? So 5 hours ago means I have 100 when it was tested, getting halved over and over to the -5th. So let's see how much she had. She started with 3,200 milligrams. Now I know it seems like a lot, but like medication, a lot of stuff's relative. Some teeny little dose of something's real potent, some big dose of another thing not real potent. It's all dependent on lots of stuff. But so we're gonna plot the points. Your graph, what's some scales out there that we use? I think time. Just like 5 and 5, probably just by 1. What's our y-axis that we used out there? You did 400s, 8 of them? Yeah, Ivy? 800s? 4 of them? I kind of like 400s. 500s? I kind of like 400s. I did it different. So 400, 800, 1,200, 1,600, 2,000, 2,400, 2,800, 3,200. That's the highest it was, right? So when she had 3,200 at the -5, I'm not going to do all these points. We know at 0 she had how much? 100. And then I'm not going to connect all of them. You're supposed to have all of them. But let's have the discrete versus continuous discussion. Do you think our dots should be connected or not connected?
Connected, because they don't all just go away at once.
So either it's her dosage is dwindling over time, or all of a sudden magically on each hour, boom, half.
That doesn't happen.
Well,
It can, but that's...
it can't. There's a fun thing in chemistry later, hopefully you get to do.
59.59 seconds.
There is a thing that it's called a clock reaction when you get to chemistry. That stuff, all of a sudden, it's just a visual that looks like it happens, though. But yeah, this would be dwindling, right? Her body would be metabolizing. This would be a continuous. Would it ever be 0?
No. Theoretically, no, but
Yeah, theoretically, no.
No, but it could be very, very small.
Yeah, probably like untraceable could be something. Maybe we could say like maybe there'd be so little in her body that there'd be like no medical instrument to say it's still in there. But in theory, if it's only getting halved over and over, there's always going to be some up in there. Okay?
Maybe it just takes out 2 of them at once.
When was 500 left? Negative how many hours?
wait.
Oh, we didn't do 500.
500 would be like right around here, right? So a little more than between 1 and 2 hours ago?
-2.2.
Yeah.
Good job, buddy.
Not easy to tell from the graph because our scale has to be a little stretched on the y, right? Not super accurate. But you could run your function. Cool.